Looks like these guys died waiting for backup. God damn it. Clicker.
Jeez. What's wrong with its face?
That's what years of infection will do to you.
So what, are they blind?
Sort of. They see using sound.
Like bats?
Like bats. If you hear one clicking, you gotta hide. That's how they spot you.
Hello and welcome to Feynman Explains, the show where we take the most creative and innovative concepts from popular movies, series, TV shows, and games and explain them to you through simple concepts that you have already learned from A-level and IB physics. So in today's episode, we're going to be talking about the hit game and series The Last of Us, specifically clickers. What are clickers and what's the big fuss about them? Did Tess just say they see using sound? Is that even possible? Well, we're going to answer all those questions and much more, so stick around till the end of the video. Firstly, in order for us to understand how all of these things that they just said make sense, we need to understand about waves. What are waves? Well, waves are generated by oscillating sources, which means they transfer energy from one point to another. What that basically entails is that, for example, feel the scorching heat of the hot rays of the sun in summer. You can feel the heat, but what it actually is the energy that's flowing through it. Basically, there are just two types of waves. Firstly, transverse waves, and secondly, longitudinal waves. Transverse waves are waves where the particle travels perpendicular to the direction of motion, as seen here. They do not require any medium to travel. So a common example of that would be light rays, which can travel through vacuum like space. The sun doesn't have any problem sending rays directly to the earth without any medium. The other one, longitudinal waves, are waves where the particles travel parallel to the direction of motion, which means they require a medium to travel, or some sort of like air or water, etc. The common example of that would be sound wave. And our topic of interest today is sound waves. It is longitudinal in nature, which means that it travels through compressions and rarefactions. The energy source determines the distance that traveled and the loudness of the sound. Like every other wave, sound wave can also reflect, refract, etc. The theme that we're going to be talking about today is echoes, right? So what basically is echo? Echo is the reflection of a wave after hitting a barrier, which basically means that some of the waves that vibrate, some of them penetrate through a wall or the barrier, which gets mostly absorbed by the wall, and some of it is reflected away. The reflection of that sound is the echo that you hear. So a common example of that would be the reflective and sound that you hear when you're inside a bathroom. When you're singing to yourself, you're gonna hear a much more fine-tuned voice and a much greater amount of repetition to what you're hearing or saying. Something like going through the top of a mountain and shouting out your name and waiting for it to bounce back at you. As simple as that. What basically this is that reflective and enclosed areas such as a bathroom or a cave provide much louder and greater amounts of echo because there are shorter distances between the walls and there is less absorbable material and more hard surfaces. That's why when you're on top of a mountain, even though it's not an enclosed area, you can still scream and then you can hear it coming back because there are less obstructions in between, right? So, and less absorption of the sound that's happening. Bats use a similar technique to navigate through caves, just like the analogy used in the video clip that we just saw. So in a movie, if you see a bat screaming towards the protagonist and to scare them away from a cave, it's usually because they're actually scared of the protagonist and not the other way around. They're trying to navigate their way out of the cave through making sounds and hearing the echoes that reflect the sound. But how can you see using sound? That doesn't make sense. Well, actually it does, and it's really fascinating. How does sound help them navigate through the entire cave and also prevent them from bumping into each other and causing a chaos, right? Remember how we learned that speed is equals to distance divided by time? Well, it gives us a judgment of how far an object has traveled and how long it took for the object to travel, right? It's just something that we came up with, and we figured out how the speed determines the distance and in relation to time. Bats actually deduce that using the formula, which is really, really similar to this, but a bit different, which is speed is equals to 2 times distance divided by time. This is because the sound actually in this case travels twice, which means it's going forward, it's getting reflected, and then it's coming back. So it happens 2 times. The amount or duration of time it takes for it to travel back to the ears is what helps them determine how far an object or an obstruction is. So bats actually create a 3D image of the entire surroundings around them by sending out echoes and then receiving them back and finding out where those objects are and how long it's taking for each echo to reflect back to it. Absolutely fascinating. It helps those bats locate where the object is and how to avoid being hit by that object. This concept is called echolocation, and it's not just used by bats, it's used by submarines underwater too, in order to navigate dark and very poorly lit waters where basically even visual aids would not be much of a help, because who knows when you're going to bump into a rock. We all know what happened to the Titanic, and those people could see it coming. So that's really fascinating, and how you can actually entail what's actually going on by just sound or listening to the distance an object is from you. It's even used in fetal scanning, where you see the scanned photograph of a baby inside a fetus, right? So the concept that clickers use echolocation to determine where objects are is quite scientifically accurate. It's not a fantasy that's been made up. You will see them constantly screaming inside the game. You will see that they're trying to move in a particular direction. Before they even start walking, they scream in that direction. They then wait for a pause, and then they start walking again, which is absolutely fascinating and very, very interesting, because that's exactly how it should be. They stop, they set their faces towards a specific direction, they scream towards it, they wait for the echo to come back, they understand the distances between the objects and the reflections that have happened, and then they move towards them, trying to avoid walls, tables, etc. Really cool stuff. So it's not just an element to incorporate horror in the game or make that gruesome sound that like keeps you captivated and motivated, but it's actually really accurate. Otherwise these creatures would not be able to navigate where they are or how they're going to go about it. So the large flower-like faces that you see is a really cool concept art, to be honest, and also it's really very accurate. This can be compared to the long ears of a bat, right? A bat has really long and rounded and big ears, right? Those ears are not just for aesthetics, which makes them really look cool, but also those ears help them pick up as much sound as possible from all directions. The flowers that you see on the face of a clicker is also something very similar to that. It helps them gather all the information from every single direction so that they can also direct sound when they're screaming at a particular direction, and also take back in from all directions, because quite frankly human ears can't possibly do that. Human ears are way too small and are in specific directions. They can't really entail all the sounds. But if you've evolved into a nasty, disgusting creature which has that big of no eyes and that big of a face, that has such a big hearing opening, I guess. I'm not a really big expert on zombies, but I guess that's what's happening. So that is really helpful for them to hear the sound that's coming in towards them and to avoid the tables or even a very, very angry Joel trying to stab them in the back. Well, and that concludes today's episode. Today we learned how clickers work and if it's scientifically accurate or not, and we even proved it using the theories that we've learned simply in A-level physics. Nothing too shabby. Well, I hope you guys understood. If you have any problems or questions, please drop them down in the comment. We'll be there as much as possible, and see you guys in the next one.